Trigonometry involves triangles. It relates the angles in a triangle to the sizes of the sides of the triangle. Previous videos we've looked at right angled triangles, looking at the relationship between the angle in a triangle and a pair of opposite sides. There were three ratios we used to compare the opposite sides. Opposite over hypotenuse was the sine ratio, adjacent over hypotenuse was the cosine ratio, and opposite over adjacent was the tangent ratio. If we consider the sine ratio, it's the size of the opposite side over the size of the hypotenuse. If this angle has a particular value, the ratio will have a particular value. So for a particular angle, there's a particular ratio in the right angle triangle. For example, 30 degrees is a half. That is 0.5. Now what that's saying is the size of the opposite is half the size of the hypotenuse at 30 degrees. Any triangle which is right angled with a 30-degree angle, the ratio of opposite to hypotenuse will be 0.5. That opposite will be half the size of the hypotenuse. Now if you even slightly change that angle, here it is 30.1, it changes the value of the ratio. Each angle has a particular value for the ratio. In a right angle triangle, it's unique to that angle. So they are paired off together. Just the same as these two are paired. An angle is paired to a particular value of the ratio. A pairing like that is called a function. A function relates one number to one other number. Another way to think of a function is a function has an input. You put a number in and you get one number out. So there's an input and an output. In this case we input the angle and that outputs the value of the ratio. And that's what the calculator does. You input an angle, you press the sine button and it outputs a number which is the value of the ratio. So that's a sine function as an input and an output. Input an angle, output a number which is the value of the ratio opposite over hypotenuse. So we can express a function using letters. We can say x is the input, then the output is sine of x. For example, input 30 degrees, the output is sine 30 degrees. So a function's got an input and an output, and it's important for the work on graphs that you realise this x here on its own is the input, it's the x coordinate of the graph. So the input's x and the output's the whole of this sine x. So input x, output all of sine x, and we call the output y because it'll be the y coordinate. So we're going to look at graphs where we input x and we output sine x. Now for this, we're going to use a bit of software that will do a lot of the work for us. There's a 30-degree triangle, it's right angled. The hypotenuse is fixed at 1 unit long. The opposite side is 0.5 units. The software measures the size of this line and it will enable us to vary that angle. On the right hand side here, there's a set of axes for the graph. Along the x-axis here is the angle in degrees, and on the y-axis is a value, numbers running up the y-axis is the numbers that are going to be the value of the ratio, the output, and along the x-axis is the input, the angle you input. So 30 degrees pairs with 0.5, there it is plotted, and there's the coordinates, 30 degrees, 0.5, that position. Now if I change that angle and make it 40 degrees, the length of this line is now 0.64. That's the value of the ratio opposite over hypotenuse because it's 0.64 for this side over 1. So this red line is the length of the opposite, but it's also the value of the ratio since we've fixed the hypotenuse at 1. So on the other side, I can plot 40 degrees input, 0.64 output. go to 50 degrees, it's 0.77. So on the other side, and go to 50 degrees, 0.77, and plot it. Now you can keep that up, plotting, in this case at 10 degrees intervals. So it's approaching, there's 0.98 at 80 degrees. Now when I get to 90 degrees, well, of course the triangle's disappeared because now the opposite and the hypotenuse are the same size, they're both 1 unit long. So the ratio there is 1. So 90 degrees, 1 is plotted, although the triangle's disappeared. Now you might think the triangle's disappeared, it's all over. But if we keep the angle going, there's 100 degrees and the triangle appears on the other side here. And it's back to 0.98 it was at 80 degrees. So we plot 100 degrees, 0.98, there it is, and so on. There's 110 at 0.94. And so on. You can keep this going, getting the ratios, plotting the points, right the way around, till it's done a 360 degree turn. But it's not over then, because it just can keep turning, it just repeats itself. So once it's completed 360 degrees, it does it all over again. So that's the case of plotting out the value of the sine of the angle. Now, just to do that for the full available angles, I'm going to look at this bit between 0 and 360, and there was the 30 degrees 0.5, and if we just go through plotting these points, you can see at 90 degrees it hits 1 and it doesn't get any higher. It then comes down, even through 0 when the hypotenuse and the opposite side again make a straight line, but this time the opposite side is 0 units in length. So it keeps going, and it's made this S shape. Now, if I were to run it back, I could do it all into the negatives as well. This has made a sort of S-shaped curve. It's a sine wave, it's called. And if you show the graph, it would look like that. So that graph is the graph y equals sine x. It's this S-shaped curve. It peaks at 1, that happens at 90 degrees, and it goes to its lowest position, -1, at 270 degrees. When it gets round to 360, it starts all over again. So we say the maximum value is 1, the minimum value is -1, and since there's one cycle of the curve in 360, we say the period of the graph is 360 degrees. Now, that's the sine curve. If I were to look at the cosine curve in the same way, sorry about that, here we go, cosine curve, it starts at 0 degrees 1. Now the cosine curve would be looking at the adjacent over the hypotenuse. From the triangle we had earlier, it would be the horizontal side of the triangle, looking at its length and plotting it. So this is the cosine. So it starts at 0 degrees 1, 10 degrees 0.98. These numbers that are coming out are the same numbers that came out with the sine wave. So the sine graph, it's actually the same numbers. They're just happening at different angles. So it would plot out like that. And it's doing the same thing. it's going as high as 1. At 0 degrees, it's 1. It's also 1 at 360 degrees. There it is, 360 degrees, 1. So the highest it goes is 1. And the lowest it goes is at 180 degrees here, it goes to -1. So the graph would look like that. Now, there's a sine graph on top of it. At first they might look different, but if we pull back and look at how it repeats itself, you can actually see the red and the blue graphs are both sine waves. Actually, all that's happened is, the one it's in red, the sine wave for the y equals sine x, if you shifted it 90 degrees to the left, it would make the blue sine wave. That is cos x, y equals cos x. So the sine and the cosine are actually the same curve. They're said to be 90 degrees out of phase. Basically, the cosine wave, if you like, started 90 degrees earlier than the sine wave. Now, complementary angles add up to 90 degrees, like 30 and 60, 40 and 50, 20 and 70. So complementary angles add up to 90 degrees. Because these curves are 90 degrees out of phase, we say we've got the sine curve, and that's the complementary case. The cosine, the complement of the sine. So the cosine means the complement of the sine. The cosine is actually the sine curve shifted 90 degrees to the left. So that's the appearance of the two graphs. What is important is you get to know the graphs between 0 and 360 degrees. I'm just going to that sort of a section in there. Can't get any more accurate than that. So between 0 and 360, there's the sine curve. And the cosine waves is the same wave, it's just starting 90 degrees earlier. So this position here, 90 degrees 1, has shifted 90 degrees to the left to become 0 degrees 1. Still, both curves peak at 1, go to a minimum at -1, and have a period of 360 degrees. Now, very different from these is a tangent graph. If we were to do what we just did with the tangent graph and plot it out, it would look like that. So it's completely different. Beyond seeing what the tangent graph looks like, we won't be doing anything with it. But if I zoom back, here's what the tangent graph looks like. It's not got a maximum or minimum, it actually heads off to infinity. So it goes up the way to positive infinity, and it heads down the way to negative infinity. That happens at 90 degrees. If you put tan 90 into a calculator, you'll get no answer. There is no value for tan 90 degrees or tan 270 degrees. The curve's going to infinity there. So the tangent curves are very different. The one thing to remember about it is these sections that are repeating themselves, like between 90 degrees and 270 degrees here, that section between 90 and 270 just repeats. So it's actually a period of 180 degrees. The shape of the curve there, it repeats every 180 degrees. So period 180 degrees. That's different from the sine and the cosine. So the next piece of work will be to look at the sine and the cosine and how to manipulate these graphs. So there's this is in the notes that are available with the video. You can download using the link in the description. There's the sine wave, but the dotted line is also a sine wave. The solid line here is y equals sine x, the one in black, and y equal cos x is in red there, dotted, just to go along beside it. The cycle of the curve is one cycle in 360 degrees, that's the period, and maximum value here is 1, the minimum's -1. There's the shapes of the curves there, between 0 and 360. The key positions are the 90-degree gaps here, from 0 to 90. That's a 90-degree gap, 90-degree gap, and so you're sort of quartering the 360. So it's split into 90-degree chunks, because when you use the graphs and when we manipulate the graphs, we need to know what happens to these red dots. These are the key positions. So the key points are at 90-degree intervals. Here in the sine x graph, it goes through 0, 0 here, 90 degrees 1, 180 degrees 0, 270 degrees -1, 360 degrees 0. You need to know this in particular, 90 degrees 1 for the maximum, 270 degrees -1 for the minimum. The y coordinate 1, that's the value of the function. 90 degrees is the input, output is 1, the value, the maximum value here is 1. So the values are up the side. So you need to know these key points, and the same on the cosine curve. So remember, it's the same wave, it's just the cosine is shifting. Its cosine and sine are shifted in phase. So this is what you need to memorise. These are the key things you need to know, and then how to manipulate the graphs. So that's the introduction to these graphs. This last piece here is what you need to know, what you need to memorise, and it's what we will be using in the next video to look at transformations, how to change the graphs. So there'll be transformations coming, and there's no real exercises available for this unit because it's just an introduction. That'll come later. What you can do is, what you've just seen is in the notes that you can download using the link description. It will cover all the stuff coming up on graphs. So, hope you found the video useful, but it'll be the next video when we cover the more important parts of